This video is to show you how to solve question number 4 from your quiz over 10.1 and 10.2. So the actual plugging into the calculator part, that I'm not going to walk you through for this quiz. I'm going to walk you through the specific steps that you wanted to take when you were answering this type of question, solving for KQ. So if you'll remember from the notes, your main focus is to make sure that you can identify if you need to deal with the forward reaction or if you need to flip and get to the reverse reaction based on the data that's provided. So your new equation that you're solving your KQ is highlighted for you in yellow. And what you're going to do is you're going to use your KQs from the 3 pieces of data provided for you. So you want to go through these one by one. What's really helpful is if you go ahead and identify that in your new equation, you have 3 specific reactants that you're looking for and 1 specific product. If they match with your data, then you're going to stick with the forward reaction. If, however, your data shows it as a product when you're looking for it as a reactant or the other way around, you're going to need to take the flip, which means that you're going to take it to the negative power. That's your reciprocal. So I'm going to walk through each one with a different color so it's easier for you to follow. So looking at equation number 1, try to find any of the reactants or the products that you have in your brand new equation in this original data. So I can see that I have C2H5OH and I need that. However, in my data, this is a reactant. And remember that in my new equation, it's being shown as a product. So automatically, I should keep in mind that I'm going to have to flip this reaction. I also need O2. So O2 right here is a reactant. Notice, however, that in my new equation, O2 is a reactant. So this should already trigger for me that there's a little bit of an issue here with this O2. If I go ahead and scan and look at equation number 2 and equation number 3, I have O2 present several times. So to make things a little bit easier for myself, I'm just going to ignore this O2. Clearly, it's not a major player, but I do want to keep in mind that I am going to have to take the balancing portions of it. Keeping on, I don't need carbon dioxide and I don't need water. So my main focus here for this data is looking at C2H5OH. That's my main focus. Remember, in my data, it's shown as a reactant, but in my new equation, it's shown as a product. So I automatically know that I need to take the flip, the reciprocal of my KQ. Now I just have to compare coefficients. Do I need to take it to a certain power? So my coefficient in my data is 1, the coefficient in my new equation is 1. So I just need to take this to the -1 power. I'm just going to have to take the flip of it. So here's what I mean by the flip. I'm going to have to take this equation and turn it around in this direction so that my C2H5OH is no longer a reactant but is a product. If I just notice that I rewrote it as a product in my brand new equation, then I don't have to physically rewrite it out, but I'll walk you through that step in a moment. So that's all I need to do here for data number 1. Moving on to data number 2, I'm going to do that one in green for you. So for my data number 2, I automatically notice that I do need a carbon, and in my data, my carbon is a reactant. In my new equation, my carbon is a reactant. So far, I don't need the flip. I'm okay with this forward reaction. Moving on to my next molecule, I have O2 as a reactant. I'm going to also need O2 as a reactant. So that might help me with ignoring the O2 from data number 1. Then continuing on, CO2, I'm not concerned with CO2. It's not in my new equation, so I can just ignore it. So for this one, I'm just sticking with this formula the way it is. I want the normal forward reaction, but now I need to double check my coefficients. So in my data, my carbon is a 1. In my new equation, it's a 2. In my data, my oxygen is a 1, but in my new equation, it's a 1 as well. I'm going to focus on balancing my carbons. If I focus on balancing my carbons, my oxygen will get leveled out because remember, it's not a major player. So for this one to go from 1 to 2, I'm just going to take it to the second power. And that's it. I'm done. Now I can move on to my last data. And my last one, I'm going to do that one in yellow. So I am looking for an H2. H2, I have it here as a reactant. In my brand new equation, I want it as a reactant as well. I also have O2. I have it as a reactant, and in my new equation, remember I have it as a reactant. But remember, O2 is not a major player. I have it taken care of in 3 separate reactions, so I'm just going to ignore it. H2O is not needed for this equation. So my main focus here is just looking at my H2. My H2 coefficient in my data is a 1, but my H2 coefficient in my new equation is a 2. So to go from 1 to 2, I just need to take this to the second power. So at this moment right now, you're done. Everything is balanced because you just focused on your major players. So in your calculator, you're going to take your 3.4 times 10 to the negative fourth, and you're going to take that to the negative 1 power. You're going to take your 2.0 times 10 to the third, take that to your second power. Your 1.5 times 10 to the negative eighth to your second power. And then your last step will be to multiply all of those KEQs together, and that's going to give you your final answer. So this final answer you can find on the answer key for the quiz. It's the exact same one. Remember, ultimately, you're going to want your final answer in 2 sig figs with no units. What I'm going to walk you through right now is your next part. So all you needed to do to get the correct answer was this. But if you wanted to take an opportunity now to double check your work and see how everything cancels, I'm going to walk you through that step right now. So remember, for our first equation that I wrote out in blue, we needed the reverse of that. That's why we took it to the negative power, because we needed to flip that reaction. So when you are rewriting it, you're not going to copy it down as C2H5OH. You're taking the reverse of it. So you're going to turn your products into reactants. So I'm going to start with my H2O and then my CO2. And then now I'm going to take my O2 and turn that into a product. And lastly, my C2H5OH and turn that into a product as well. So now it matches my new equation. Now what I need to do is I need to deal with my coefficients. Everything was taken to just the negative 1 power. So the negative, I already flipped it. The 1 power, I'm just going to copy down the same coefficients. So my H2O needs to have a 2. My CO2 needs to have a 2. My O2 needs to have a 2, and my C2H5OH, it just has a 1. So I flipped my reaction, but remember, this is an equilibrium, so I'm going to go ahead and finish that equilibrium sign out. And that now is representing my KEQ flipped to the negative 1. Now I need to do the same thing with the next 2 reactions, my 2 and my 3. For my 2 and my 3, I didn't need to reverse any of them. I stayed with the forward reaction. So I'm just going to copy them down the exact same way that they were written out for you with your data. What I do need to do is I need to manipulate my power. So remember, you took everyone to the second power. So the 1 now becomes a 2, the 1 becomes a 2, and the 1 becomes a 2. And that's it for your second reaction. Now you just have your third reaction. Your third reaction, again, you stuck with the forward reaction, but you just took it to the second power. So I'm going to rewrite it out as H2 and then O2. And remember, you just have H2O. So 1 to the second power, you're just going to have a 2. Half to the second power, you're just going to have a 1. 1 to the second power, you're going to have a 2. And at this point now is where you can cancel everybody out. And you can see what is left over. So what I'm going to do now is I'm going to walk through each one and cancel out anyone that's in both a reactant and in a product. That means I don't need them. So I immediately see 2 H2O as a reactant and 2 H2O as a product. H2O is gone, and I had 2 for both, so I don't have any left over. I also see a 2 CO2 and a 2 CO2. Those cancel out. I don't have any left over. Notice how my oxygens canceled. I have 2 O2 as a product, and I have 2 O2 as a reactant. So all you now have remaining is your 2 carbons, your 2 H2s, and your diatomic oxygen, your O2. Those are your only reactants remaining. So I'm going to go ahead and rewrite them out. 2H2 plus 2C plus O2. And it wouldn't really matter what order I wrote them out in. Now as I go back and I look for my product remaining, my only product remaining is C2H5OH. So now I can finish off my equilibrium equation. So this part that I just walked you through here, that I circled in blue, this is just an opportunity for you to now double check your work so that you can confirm that your final equation matches the equation that was asked of you in the problem. But the only actual work that you needed to do to solve the question was this part up at the top where we did the actual math. If you just did that part, you're still going to get the same final answer. The part that I circled in blue for you is the material as a way for you to double check your work. And that's it. Just make sure you're okay with your calculator skills and your final answer is still the same final answer. It's posted on the answer key.